Worksheet 8. And your blue reference sheet. Okay, I have a warm-up. This is very similar to number 3. On worksheet 7A, maybe? It's a question about a Ferris wheel. Anybody check in for me? Is that a question about a Ferris wheel on 7A, number 3? Okay, this is similar to that. Ferris wheel has a diameter of 30 feet, so the radius for our Ferris wheel is 15 feet. Everybody good? It's once. Okay, I think I may have left out a word. It turns once or rotates once every 48 seconds. It makes one revolution. Okay? So it doesn't seem like they gave us enough information to find the linear speed. But one turn is how many degrees? 360, which is how many radians? So 2 pi radians in 48 seconds. Are we now at an angular velocity? Okay. This is radians per time, so it's an angular velocity. So then it says find the linear speed in feet per second, so we would just need to multiply. That was feet, sorry. Radians disappear, and we just get, oops, 48 was down here. We just get feet per second. 15, I don't think I have a calculator, maybe I do, I don't know if it's dead. 15 times 2 pi divided by 48, 1.96, 2 feet every second. Not super fast, right? All right. I'm going to go super fast, and it's that big of a... All right. Unit circle, announcement. I'm moving the quiz till Monday. Okay? Everybody good with that? So you practice it again tomorrow, and then you can practice over the weekend. I will have some extra blank ones you can have tomorrow, okay? But for tonight to practice, there's ones in the packet. All right. You need to know these definitions for Tuesday's quiz, not as much. I use them when I do the unit circle because well, not to draw it, I have it memorized, but sine is y over r and the cosine is x over r. And the unit circle ordered pairs are cosine and sine. Alphabetical again, guys, right? X coordinate, y coordinate. So cosine goes with x. Here it's x over r, and sine goes with y. All right, tangent is y over x. What else did we do that was y over x? Yes, the tangent is really the slope. Okay, the tangent is really the slope. Now, we're going to talk about how to use that on the unit circle in just a second. All right, first it goes through reference angles. I hope you're all comfortable with this. A reference angle is always the angle to the nearest x-axis. So if I had an angle here that was 10 degrees in here, that 10 degrees is not the reference angle. Everybody remember this? You have to find the, oh, that doesn't look like degrees. Looks like I labeled it 10 degrees in there, okay? But you have to find the angle with the x-axis, so it would be 80 degrees, or negative 80, but the angle in the triangle would be 80. All right, I always think of this bow tie, right? It's got to make, it's always this or this, or this, or this, depending what quadrant we're in. Are we good? This is just the review of what we just talked about. Remember on the unit circle, all students take calculus? Do I need to go over that anymore? The A is for everything, all is positive. The sign is the only thing positive in the second quadrant because it's Y. The Y-axis is positive and sign is Y. Down here, the only thing that will be positive is tangent because X and Y are both negative, but when you put them over each other, you get a positive. And in this quadrant, the cosine, because the X is positive, but the Y is negative, so cosine is positive. Anybody have that memorized differently or have a question about that or? Okay. This is more about the reference angle. I'm just gonna go, this is how to find the reference angle in degrees, but I don't think we need to memorize crazy patterns. This is how to find it in radians. This is also the quadrantal angles. I'm just moving on. We've done this before. So sketch each angle, then find its reference angle. If it's in degrees, you must answer in degrees. If it's in radians, you must answer in radians. Everybody good? So 330 degrees, you're going to draw a little sketch that shows starting here. I would turn all the way around to, which quadrant am I going to end in? Fourth quadrant. Okay. That's on the quiz. It asks about the quadrants. And what is the angle that is the reference angle in here? Is the rest of the way back to here. So if you did minus 360, you'd get a negative 30, but it can't be negative. The reference angle has to be positive. Or if you did 360 minus 330, it's a 30-degree reference angle, and they use this little guy for a reference angle. Anybody not remember that? Okay, we have two options here. Some of you can leave it in radians and answer. Most of you need to change it to degrees because that's the way your brain works, right? So if we want to change this to degrees real fast, the pi is going to divide out. 3 times 180 divided by 4 is 135. Anybody helping me? Negative 135, anybody? Okay. The other thing to do is just...
It's taking the fraction and taking away pi or 2 pi?
Yes. Okay. So negative 135 is down here. So we're actually supposed to label it, I guess, negative 3 pi over 4. But what we need is this angle. Okay. What would be the difference to this line? What's that line called? So 180 and negative 135 would be a 45-degree angle in here. But can I answer as 45 degrees? No. 45 degrees is pi over 4. Everybody okay? A reference angle is never negative. Yes, great questions. Just to reiterate, the reference angle is always positive, no matter what the original angle is, because it is simply an angle to the nearest x-axis. All right, 9/6, which makes no sense to me because it reduces to 3/2. So it would look like this. What is that in a particular quadrant? It's called a quadrantal angle. Okay. It doesn't have a reference angle. And it's not in a particular quadrant. Did I forget to label this one? This one was in quadrant 2, right? All right, number 4, 11 pi over 6. Anybody know where that is? 4th quadrant over here. And the reference angle, if you had a unit circle for this quiz, which you might, you could just look at it, right? And say 11 pi over 6 is really 330, so it's really a 30-degree reference angle, which is pi over 6 in radians. Okay, 165 is not a nice one. It's not on our unit circle. What quadrant is 165 in? 2nd quadrant. When you go into the 2nd quadrant, you always have to find what? How much further to the 180 line you got to go, because that's the x-axis. So 180 minus 65. Thank you. And that was quadrant 2, by the way. All right, negative 5 pi over 9 is also not a nice one. So we're going to multiply by 180 over pi because we think in degrees best. Negative 100, anybody type in that for me? The pi's divide out, so it's 5 times 180 divided by 9. Okay, so negative 100 would put me in what quadrant? Quadrant 3, right? But what's the reference angle?
4 pi over 9.
I think you're right, but this, if we went 100 this way, it would be 80 degrees as the reference. This was negative 5 pi over 9. If we change 80 degrees back to radians, we get 4/9. Martin just thought in radians. He said this line is pi. So pi minus 5 pi over 9 is 4 pi? Yes, yes. But could you all get there eventually, whether you change it to degrees or not? Okay. This is when you're given an ordered pair. So if you were given the ordered pair, go left 9 and up 12. You could do Pythagorean theorem to find this hypotenuse, right, guys? Comes out 15. And then the angle you're talking about is down here. And you just do all the functions, opposite over hypotenuse, etc. So I'm hoping you're good with this already. So let's do number 7. Might be on the back. Am I on the back already? Okay, number 7. What quadrant is 2, negative 5 in? 2 to the right, down 5. So you connect it back to the origin, and you make it a bow tie triangle. Everybody good? Nobody's going to make the triangle wrong, right? It's not like this. Okay, doesn't work that way, because then you're going to put theta in the wrong spot. The angle is with the x-axis here, so this is the angle we're going to use as far as if you wanted to label them. This is x, or adjacent to that angle. This is opposite of that angle, which is y, because it's up and down. And this is the hypotenuse, or r. And we didn't do Pythagorean theorem yet. What goes on there? 2 squared plus, oh my gosh, please don't square negative 5 and get negative 25. Then you're going to have a hot mess. Get 29. Yes, okay, I didn't write that well at all. Equals hypotenuse squared 29. So square root of 29. Okay. All right, we want all 6 trig functions. Lovely. So we have the sine. Okay, Sine, guys, practice. Sine is y over r. Y was -5 from the ordered pair over square root of 29. Okay, if you didn't even want to draw this, in theory, you could have done 2 squared, x squared plus y squared equals r squared. I always draw. Okay, then if you multiply by square root of 29 over 29, you get -5 square roots of 29 over 29. All right, cosine? Somebody help me out? 2 over square root of 29, which becomes,
2 times square root of 29.
okay. Tangent,
By
opposite over adjacent, or slope, which is y over x. We were given the numbers to do that one, -5/2. All right, then cosecant. Now, where's it easiest to flip this over, guys? That very first guy, right? Or to do hypotenuse over opposite. Okay, make sure it's negative. I didn't write the negative very well. All right, secant. Flip the cosine over. So it's square root of 29 over 2. And cotangent is -2/5. Questions? We good with that? Once we draw the triangle, we can do all that fun? All right, the rest of the time, most of the rest of the time, we're going to be using the unit circle to find a whole bunch of special fun. Okay? I'm going to start by talking about quadrantal angles real fast. This is the reason, these are the reason you have to know this definition. Cosine is x, sine is y. So cosine of 270, where's 270, guys? You don't have this one. Cosine, 270 is down here, right? What's that ordered pair?
0.
Okay, cross 0, down 1. Cosine is x, so the answer is just 0. Pi over 2 is up here, which is over 0 up 1. Cosecant, well, this is cosine, and this is sine. Which one am I doing the reciprocal of for cosecant? Sine. Reciprocal just means put it over 1 and flip it over, so I still get 1. Cotangent, -90. -90 is down here. Ordered pair, cross 0, down 1. Okay, what's tangent again?
Opposite over adjacent.
Okay, but opposite over adjacent isn't going to help you for this question. Tangent is y over x. So for cotangent, we want x over y, right? Everybody with me? X over y, 0 over -1. If you get that wrong, you can't leave it like that. You leave it like that, I'm counting it wrong. What is 0 divided by -1? I heard both undefined and 0.
0. You can put 0, -1, and 0.
Okay. It is 0. When the 0 is underneath, it's undefined. Does that help anybody, that little phrase? When the 0 is underneath is when it's undefined. Okay? You can type it in your calculator. 0 divided by -1 will give you 0. So the big answer is a donut. All right, real fast, dividing fractions. This is just to show you something that happens, guys. Look at this real quick. What do you do when you divide fractions? You flip the second one over. What happens here? Everybody good? So if I had this, I'd flip the second one over. The 2's would divide out, right? And this is off the unit circle, or could be, no, it's not, the 2/3 is, but if this was on the it'd be 2/3 times 3 over square root of 3. These would divide out. You get 2 over square root of 3, or 2 square roots of 3 over 3. Okay, what I'm showing you, when you have both of them divided here, did we really need those 2's? Were the 2's part of our answer? No, they're going to divide out. Okay, you ended up with this over this, or here, this over this, which we had to rationalize. I'm trying to save you some time and energy. So the sign at this point, look at your unit circle. I'm really supposed to be helping you do this without the unit circle for these questions. 7 pi over 3. Pi over 3 is 60. That says 5 pi over 3, doesn't it? 5 times 60 are 300 degrees. So this is a 30-degree reference angle. No, it's not. 300 is what, guys? 60-degree reference angle. So if I was using the stuff we did yesterday, you'd have x square roots of 3, 2x, and x. I don't know that any of you want to use that. You want to use the unit circle stuff? It went over what? Smaller than down, right? So it went over 1/2, but down square root of 3 over 2. It's going to be the same thing. If you did sine, you did opposite over hypotenuse, you put x square root of 3 over 2x. You'd still get square root of 3 over 2. What am I messing up? I didn't do something. What quadrant are we in? Yeah, this one is negative, right? So the sign is the y, the sign is negative square root of 3 over 2. If you had a unit circle in front of you, all you had to do was find 5 pi over 3 and tell me the y coordinate, yes? Okay, cosine of 210 would be 180 plus another what? 30 degrees? Okay, if you did it from what we did yesterday, we did short leg, hypotenuse, long leg. Which ones are negative in this quadrant? Not, the R value is never negative. The hypotenuse is never negative. Okay, so if you had it looked at the ordered pair, you went over further than you went down. So we went left square root of 3 over 2 and down only 1/2. That's the ordered pair that would sit out at the end of this. So what's cosecant? It is hypotenuse over opposite, or it is the reciprocal of sine. Is this the sine right here? So can we just flip that over? Right? You could have done hypotenuse over opposite. 2x over negative x would just be negative 2. All right, negative 315 is around this way. It ends at a 45-degree angle. So we'd have x, x, and x square roots of 2. I don't want to do it that way. Can you just tell me what the ordered pair would be out here? Square root of 2 over 2 and square root of 2 over 2, right? So the cosine is the x coordinate, so square root of 2 over 2. All right, I'm not even going to bother to draw the triangles. We're just going to use the unit circle. Everybody ready? When you have made the unit circle with a radius of 1, now the sine is just the y value, the cosine is the x. So it's cosine, sine. And how do we get tangent? Tangent is sine over cosine, or y over x. Okay, don't get that wrong. All right. It just says here, it's very helpful to have the unit circle memorized. You can quickly perform calculations involving them. All right, this wants the tangent of 5 pi over 3. 5 pi over 3, where is that on your unit circle? Down here, isn't it? Everybody find it? I'm thinking, you can double check me, but because this is a 60, I'm thinking I went down further. So I went to the right 1/2 and down square root of 3 over 2. Is that right, guys? All right. So what is the tangent? Remember that weird slide about fractions I did a minute ago? That was for this question. Because when you do this disaster divided by this disaster, what did we just learn? The denominators are always going to disappear and divide out. So you just get -3 over 1 or -3 as the, what? Square root of 3. Thank you. Wow. It's like, how do we get a 3? Oh, sorry. That was the tangent. What did I just do? Tangent is y over x. It's negative square root of 3 over 1 or just negative square root of 3. Okay. That's using our unit circle. Here we go. Ready? You have a ton of these on the quiz Tuesday. So you will have a unit circle for it. So you go to 7 pi over 6, which is right here. And for cosine, all you do is write down the x coordinate, right? So negative. Okay. Secant of a negative 3 pi over 4. I'm already confused. This is how I would do it. Everybody watching? I'd go 3 pi over 4 is around 135 degrees that way. But because it's negative, I'm supposed to be going this way. Okay? So it's really 5 pi over 4. I just look for the symmetry in the picture. Is that making sense?
Yeah.
Okay, so I looked positive 3 pi over 4, but I went, whoa, wait a minute, I'm supposed to go negative. So I'm here. Here's the coordinate I'm talking about. Secant. Which one is secant the flip of? Not that it matters. They're both the same value, but it's a flip of cosine, which is this. So I have negative 2 over the square root of 2. Negative 2 square roots of 2 over 2, which is just negative square root of 2. You do enough of those, you'll remember that, but it's okay to show work and need to write it out. This is the biggie because we have a quadrantal angle, right? Tangent at pi over 2. Tangent at pi over 2, the ordered pair is 0, 1. Tangent is y over x, so I have 1 over 0. When the 0 is underneath, it is undefined. If you leave that answer, I'm going to count it wrong. You have to tell me that is undefined. The slope, remember we said tangent is slope? Right there at 90, the slope of a vertical line is undefined. Number 15, I'm a new unit circle for us to look at here. 4 pi over 3s are right down here. So there's our ordered pair. Cotangent, well, tangent is y over x, so cotangent is x over y. Do I need to put negative 1/2 divided by negative square root of 3 over 2? What did you learn a minute ago? It's going to end up with just this, right? Because when you flip it over, the 2's are going to divide out. So it's the x over the y. Now 2 negatives are going to make it positive. And the answer will be rationalized to square root of 3 over 3. Watch your signs. Okay. Blech. Negative 5 pi over 4. You could change it to degrees, right? You could type negative 5 times 180 divided by 4 on your calculator. You hate. I just look at the uniformity. I look at the triangle and go, well, 5 pi over 4 is all the way around at another 45, right? I'm sorry, halfway around at another 45. So negative just means I went this way and another 45. So I'm at that ordered pair. So the ordered pair is negative square root of 2 over 2, positive square root of 2 over 2. So the cosecant flips which of those over? The the sine, so the y. Anybody remember what happened when we flipped that over a minute ago?
It was just square root.
Yes. 2 square roots of 2 over 2 is just the square root of 2. Positive. Okay, cosine at pi. Right there, ordered pair, cosine is x. So the answer is -1. Number 18, going down to 270, okay? So the ordered pair is 0, -1. Tangent is y over x, so cotangent is x over y. Is the 0 underneath, so it's undefined? No, when the 0 is on top, it is 0. Sine of 90, another quadrantal angle up here. So the ordered pair is 0, 1, and where do we look for sine? In the y spot, so the sine is simply 1. Okay, tangent of -60, figure it out. So ordered pair. Tangent is y over x. That's going to simplify just to -√3, right? You can do a bunch of flipping if you want, but it's just going to be the y over the x. Literally, you could ignore the denominators and put the y over the x. Okay. It says tomorrow, but we moved this to Monday, right? So the homework check-in quiz on all the learning targets are on Tuesday. Tomorrow we're going to spend some time graphing. Your homework tonight is on 7B. And I assigned quite a few of them. I know it looks like a ton of problems, but that's because you don't have to do any work, right? You're just looking at the unit circle for most of them. Do you get what I'm saying? Okay. Do we need to talk? I skipped this one. Do you want me to go back and do this guy? When you have an ordered pair of -12, 4. If they gave you an ordered pair of -12, 4, you would go left 12 and up 4. You're always using this angle in here. So if we do Pythagorean theorem, somebody type that for me. 144 plus 16. $160. Square root of 160 would be 16 times 10, or 4 square roots of 10. The hypotenuse is always positive. All of these are going to reduce then, right? You could reduce them before you even started, but sine would be opposite over hypotenuse, or 1 over the square root of 10, or square root of 10 over 10. Cosine would be adjacent over hypotenuse. This would reduce to -3. So we'd have -3 square roots of 10 over 10. Tangent would be y. Look at, back up here, we started with an ordered pair, right? It's just y over x, or opposite over adjacent, but 4 over -12 is going to be -1/3. What's the flip of sine? Which function? Cosecant. And the easiest place to flip it is right there. What's left? This was 1 over square root of 10, so it's square root of 10 over 1. Secant, flip this over, and we would have square root of 10 over 3, and it was negative. Cotangent would just be -3. All right, just a little more practice on that. Anybody have a question? Is there an angular linear velocity question on the homework anybody had, or anything like that? I'll stop the video.